In this lesson, we'll be learning about factoring quadratics to solve them. Recall from earlier in the year that factoring is when you rewrite a number as a product of prime factors. So earlier in the year we did 20, and if we wanted to find the prime factorization of 20, we did a factor tree and we broke it down into 5 times 2 times 2, and eventually we wrote that 20 is equal to 2 squared times 5. Now what we're going to do is we're going to take something that looks like this, so it's a quadratic expression, and we're going to factor it into something that looks like this. The 2 is prime, x plus 5 is prime because we can't break it down further than that, x plus 1 is prime because that doesn't break down further either. So by the end of this lesson, you'll be able to start with something like 2x squared plus 12x plus 10, and you'll be able to rewrite it as something like 2 times the quantity x plus 5 times the quantity x plus 1. Now there's lots of different types of factoring, and the first type that we're going to look at is called factoring out a GCF, or factoring out the greatest common factor. What you'll do is you'll look at all the terms. There might be 2, 3, 4 terms, but you'll look at all the terms and you'll find the greatest common factor of each of the terms. And then you will pull that out like a division problem. It's basically the opposite of distributing. So think of distributing, and then the inverse of that is called factoring. When you take out a GCF, it might be numbers, it might be variables, it might be some combination of that. And also, if your first term is ever negative, you want to also take out a negative as part of your GCF. So let's look at 2 examples here. For this first one, 2xy squared plus 4x. First we're going to find the GCF. So first we'll do the numerical part. 2 and 4, they have a GCF of 2. Then we'll move on to x's. The first term has a first power of x, the second term has a first power of x, so they have a first power of x in common. Then we'll move on to y's. The first term has a y squared term in it, the second one doesn't have any y's, so we can't factor out any y's because there aren't any in common between the 2 terms. Then you'll fill in the parentheses with what would be left, and you have to kind of work backwards. You have to ask yourself, 2x times what is 2xy squared? Well, 2x times y squared equals 2xy squared. So here I would put a y squared. And then you would ask yourself, 2x times what equals 4x? Well, 2x times 2 equals 4x. So the value in the parentheses is what's left over after you factor out that GCF. For the second question, we've got 3 terms, but there's really not much different other than that. So first we're going to look at -3, -9, and 15. Because the first term is negative, I'll be factoring out a negative, and 3, 9, and 15, they're all divisible by 3. So I'm going to be taking out a -3. Then I look at the x's. The first term has 3 x's, 3 powers of x. The second one has a second power of x. The third one has a first power of x. They all have at least 1 power of x. I'm going to take out 1 power of x. Then I'm going to ask myself, 3x times what, or sorry, -3x times what equals -3x cubed? -3x times x squared equals -3x cubed. And then I ask myself, -3x times what equals -9x squared? Well, -3 times +3 equals -9, and x times x equals x squared. And then I ask myself, -3x times what equals +15x? -3x times -5 equals +15x. So this value, after I take out the GCF of negative 3x. That is what factored form looks like.